Hello and welcome to Feature in 5. Today I'm back here with Glenn. We're going to cover stretch clusters in VMC, is that right?
That's right.
All right, cool. Let's get into it.
Yeah, so as you can tell here, we're already logged into our VMware Cloud and AWS portal, and I have an SDDC already configured, but this SDDC is our standard multi-host SDDC, which means that all of the hosts are in a single Amazon availability zone.
Okay.
What I'd actually like to do today is show you a stretched SDDC, which is going to consume multiple AZs. So we're going to start off by signifying that we want a multi-host, right? Not our single host proof of value trial instance, but actually we want to go all the way up. So we're going to deploy a stretched cluster.
This one goes to 11.
This one does go to 11. We got to give the simple name, multi-AZ works here, and then we're asked how many hosts we'd like to configure. We'll just go ahead and select the default because I don't want to get yelled at for using too many of these things. Next, we're asked which AWS account we'd like to connect to. This is just so that we can locate your VPCs and figure out which AZs you want to deploy in. And then we're asked which Amazon virtual private cloud you would like to connect. Now, when we select this VPC here, what we're selecting is what we'd like to connect to the logical workload network. So this is, if you had any EC2 instances or if you wanted to use Amazon services in conjunction with your existing workloads, GOTS and COT software VMs inside vSphere, you'd want to select whichever VPC those services resides in, so you don't have transitive routing through Amazon.
Right, okay. So this makes sure they're all in the same subnet.
Yep, and it lets us control those costs by making sure that we don't have any egress fees.
Right.
Yeah. Okay, now as we can see, the wizard here is telling us that we need to have at least one subnet. So I'm going to go ahead and I'll select US West 2A as my first subnet. You'll notice that when I select the second one, though, it says, hey, since you have a stretch cluster, you actually need to select a second one. We'll go ahead and select 2B. Now, what's actually happened under the covers is we've designated the preferred and non-preferred fault domains for our stretch cluster by selecting those two availability zones. This remaining availability zone, US West 2C here, will actually deploy the witness host into whichever one is not selected.
Got it.
Okay, so that's how that works.
Sure.
Yeah, nice simple wizard. If you know nothing about vSAN stretch clustering, we just walk you through the process, answer all the questions, make it impossible for you to mess up.
Right.
But if you do know what you're doing, you do have an element of control in here.
Okay.
Finally, we're asked, just for a management network, this is just the IP addresses we're going to use for vCenter, NSX controllers, vSphere hosts, all that kind of stuff. If we want to link it back on premises. We acknowledge our charges, admit that it's going to take 2 hours to deploy this, and then hit go.
Hell of a lot quicker than when I set it up myself.
That's very true. And as we said, in the real world, this takes right at 2 hours for this process to run. We've sped it up here because clearly, 5 minutes is not 2 hours. But we go through and deploy the first standard cluster in the first AZ. Then we deploy the secondary AZ, the vSphere host in the secondary AZ, provision our witness host in the third AZ, and then go through and configure an actual stretch cluster inside vSAN using those 3 fault domains and building out the environment. As we can see here, our deploy is done and our cluster is ready to go. So I'll just go ahead and click in. We can see here we've got 6 hosts, 64 terabytes of storage. And if we go take a look inside Virtual Center, we will discover just a standard cluster, right? This is still just vSphere. The only way that we actually can see that this is actually a stretch cluster is if we go in and take a look at the fault domains. Boom. It is a stretch. It is enabled. We can see that US West 2A is, in fact, our preferred fault domain. Remember the first one we selected? And we can see our witness host right there in there.
So what happens if it breaks?
Great question. So this is the advantage, right? Because as we know, Amazon availability zones, they only carry a 3 nines uptime. So you need to have resiliency in mind. You need to plan for failures. And customers bringing workloads into VMware Cloud and AWS that can sustain that, who have business critical applications that require higher availability, what they can do is they can come in and deploy a stretch cluster. And of course, vSAN is going to take care of the availability just by making sure that we set our policies appropriately. But we also have compute policies inside the service, which enable us to control workload affinity and tagging. So you'll notice here I've got this US West 2A and US West 2B pinning my VMs to a particular availability zone with a preferred. This is the equivalent of a DRS should rule.
Okay. So this is like a future is now type thing.
Exactly. Yeah, this is another one of those instances. So now with that established, let's just come back. And in the background, we've gone ahead and asked someone to do a bad thing, and as you can see, we've just lost an entire availability zone. So half of our cluster just died instantly, and anything that was running in the US West 2B region is hard down crashed. Now, if we just sit here and wait a second, vSphere high availability is just going to do its thing. It will detect the fact that those workloads have crashed, and it restarts them in the surviving AZ. As we can see, all those workloads are now running in the 2A zone.
Awesome.
Now, I had some workloads that did not have a mirroring policy configured. And if we look down here, you'll notice they're still disconnected. That's because the underlying storage for these virtual machines is not available because they weren't running a mirroring policy. But if we sit here and wait, SRE is going to get in there. They'll get with Amazon. We figure out what was going on. In this case, we're able to bring that host back up. And you'll notice that as the hosts are actually returning, as soon as vSAN has access to those objects, vSphere availability is able to come in and actually restart. And then finally, once the cluster is all the way back up and running, those compute policy rules kick back into place and they move our workload back where it's supposed to be. So we automatically reestablish that high availability, resetting the environment, prepared for the next failure should it occur.
It's a really compelling, easy way to increase your availability on VMC.
Absolutely.
All right, thank you, Glenn. For more videos like this, check out storagehub.vmware.com.